Hi, my name is Emily Olowinski, and this is my Geology 102 presentation. If I could travel back in geologic time, I would visit the Cambrian period because I absolutely love the explosion of sea life. Let's set the scene. The Cambrian period begins 541 million years ago and ends about 485 million years ago. Sounds like just yesterday, right? So what was going on during this time? On Earth, we see one large ocean. This is the Panthelastic Ocean, and then one smaller ocean. This is the Iapetus Ocean. We also see a couple of continents. These are Laurentia, Baltica, Siberia, and the biggest one of them all, Gondwana. What will these continents eventually become? Laurentia becomes part of North America, Baltica becomes northwestern Eurasia, Siberia will become what we see as Siberia today, Baltica will become Scandinavia, Eastern Europe, and European Russia, and finally Gondwana will become the rest of Europe, most of Asia, and the rest of the southern countries. The climate around this time was about 22 degrees Celsius, as the Cambrian was in the middle of two major ice ages, one that began during the late Proterozoic and then one that started during the Ordovician. During the Cambrian, there was no significant ice formation, and land temperatures remained mild. Since the Cambrian was a time when there was little ice formation, this means that sea levels were quite high. This key factor led to the formation of new areas for sea life to grow and develop, as the ocean covered lots of land, leading to shallower waters in these areas that ocean covered land. In these shallow waters is where sea life really thrived. Another key factor that helped lead the Cambrian into its mass explosion was the amount of oxygen that was in our atmosphere and in the water. This increase in oxygen was created by the cycling of carbon dioxide into oxygen by cyanobacteria going through photosynthesis. All of these key factors helped lead to the Cambrian explosion. This explosion began 530 million years ago to about 541 million years ago. This explosion of life was characterized by the massive fossils found of sea life. At the start of the Cambrian, we only really had small multicellular organisms that went through photosynthesis and ate carbon dioxide and processed light to create oxygen. Most of these organisms, all they could do was produce oxygen. These organisms first appeared about 571 million years ago and had no hard parts just yet. From this, many new forms of sea life were seen. The biggest formation we can see is the beginning of sea life with hard parts. During this time, we see lots of arthropods. Arthropods are animals such as insects, crab, lobster, and spiders, although these are more modern evolutions than what we used to see in the Cambrian. One of the main arthropods we see during this time are trilobites. Trilobites truly ruled over this time period. We first began to see them in the earlier Cambrian period around 542 million years ago. One of the earliest known species of trilobites was actually found in Nevada. There are more than 15,000 species of trilobites that we see during this period. The biggest thing that we see about this trilobite is how complex they really were for their time. We see functional eyes, which they use to better see around the ocean and to better hunt their prey. They have complex digestive systems and hard calcite carapaces. In simpler terms, carapaces are the hard calcite shells that we see on trilobites. They needed these shells to protect themselves from other marine animals. At the time, these were the most advanced sea life on Earth. Although they were complex during this period, they came from much simpler organisms, some that resemble worms or jellyfish-like organisms. Although we wish to know more about these trilobites' earlier ancestors, we really haven't found much evidence on how they truly evolved to what we see them today. Trilobites mainly lived in shallower waters, places where they could walk on the sand below and eat their small prey. These trilobites ruled for over 270 million years, ending their glorious reign during the Permian. Some similar animals to the trilobites that evolved during this time were Wiwaxia, which looked like ovals covered in scales and had pointy arms coming out from the top. These Wiwaxia are soft-bodied. We also see Opabinia, which looked a bit like shrimp but longer, and which the Opabinia had eyes that they could actually see. We also see Hallucinia, which look like worms with spikes on top of them. These were all members of the arthropods as well. But what else do we see during these times? We also see the development of mollusks. Mollusks are snail-like creatures that live in the sea, characterized by their calcium-rich shells. We first began to see mollusks about 545 million years ago. These mollusks mainly ate small organisms and things that laid on the ocean floor. There are three main types of mollusks that appeared during the Cambrian. We see gastropods, monoplasphorians, and rostroconchas. These are mainly squids, scallops, snails, and sea slugs. These all likely evolved from flatworms. But what are flatworms? Flatworms are a species of Lobopodia that are characterized by their long flat bodies and small legs. The next thing that we are able to see are worms. Worms began to be seen on the fossil record about 541 million years ago. These worms were characterized by their hair-like bristles that completely covered their backs. These were also soft-bodied organisms. Lots of these worms have been found in the Burgess Shale sites. These worms also evolved from flatworms that I had mentioned earlier. The next species we see are sponges. Because a lot of these oceans that covered lots of land and created shallow oceans that we see a lot of coral reefs during this time, and in these coral reefs, we see lots of sponges. These sponges thrived in the shallow reef environment. We began to see these sponges first about 640 million years ago, and we still see sea sponges today. These sponges look like the ones you have on your kitchen sink, but much larger and rounder, like a large sponge ball. Finally, the last abundant species that we see are ectoderms. These are phallem-type creatures. These include animals such as sea stars, brittle stars, sea cucumbers, sea urchins, sand dollars, and crinoids. These ectoderms first began to appear around 542 million years ago, and we still see them today. During the Cambrian, we mainly see these as spiny-skinned marine animals. But what was plant life like during this time? During the Cambrian, we mostly see algae-like plants and very primitive seaweed. On land, we also see primitive plants and that were on Earth's continents during this time. Now let's talk about what ended this glorious time of thriving oceans and mass sea life. This time is known as the Cambrian Ordovician mass extinction. At the beginning of the Cambrian, we first saw an explosion of life because of the large flux of oxygen into the atmosphere and the oceans. When the oxygen levels began to decrease, this is where we really saw the downfall of this great period. The oxygen level began to decrease beginning about 485.4 million years ago. But what caused the oxygen to deplete? During the Cambrian, oxygen levels weren't always at its peak. During this time, we saw many periods where oxygen levels were extremely high and where oxygen levels were extremely low. During the high periods, evolution really skyrocketed, and during the low periods, little evolution took place. Scientists are still a bit confused about how these oxygen levels were caused. Low oxygen levels were caused. The final nail in the coffin began in the Ordovician Ice Age. This ice age began around 488 million years ago and lasted till about 443 million years ago. This ice age caused sea levels to drop as ice accumulated at the poles. This took away water from shallower areas on Earth. This ended up destroying warm tropical waters and took away shallow reef environments. This killed a lot of the species we talked about earlier and completely changed Earth's environment. This cooling of water helped to further trigger more ice ages, and we see primitive plants on Earth die and other many species in our ocean. Thank you so much for joining me today, and that's why I love the Cambrian period. Have a wonderful day!